right? Good morning, students. Okay, so in yesterday's class, we are discussing about the experimental study of photoelectric effect, and we have seen the construction, right? So in yesterday's I have drawn this ammeter and voltmeter at the top side. So you can draw there, or according to your NCERT, you can draw here. So if you draw here, then what it will calculate ammeter? It will calculate the current. So if I draw here, then also these are just connecting wires, right? These are just connecting wires. It will calculate again the current. It is produced by the photoelectrons, right? So this is the potential which is calculated in between the two terminals. Apart from that, nothing. You can draw here or you can draw here. Don't worry about that, right? So coming to the point. So construction now again no need to explain. Is that clear? Right. So now source will be there. From the source, light will go. What type of light? Ultraviolet light. Why ultraviolet light? I think already we studied in the last class why we have to consider this light. What do you mean by evacuated tube or evacuated chamber? So inside gases will be present or not. So electrons will come out, right? So the electrons will come out due to what? Photoelectric effect from the cathode. Cathode is positive or negative? Cathode should be positive or negative in the initial case. It should be negative, and the anode it should be positive. Initially cathode should be negative and the anode should be positive. We know that, and this is the commutator. Due to this, what we can do? We can change the terminals of cathode and anode. Initially it is negative and anode is positive. Now we have to change the terminals in the sense by using this commutator or key, we can change. Right? So now rheostat variable resistance, we can vary the things, and the high voltage battery, this is also variable. Right? So we can vary this. How we have to vary at all? I think yesterday some basic things we have seen. So we'll quickly revise the things and we'll close the topic. Okay? So first thing, what is that? Try to revise the point. So we have to talk about intensity. Already we discussed about this. A quick revision about intensity. If intensity increases, what will happen? If intensity increases, number of photons falling on the cathode increases. If number of photons falling on the cathode increases, number of electrons ejecting out also increases. Number of electrons ejecting out also increases. If number of electrons ejecting out increases, photoelectric current increases. Photoelectric current increases. We have drawn the graph also for this. Again, all the graphs I will draw at the end. Okay. So intensity and photoelectric current graph, we have seen it is a straight line passing from the horizon. Next point. So after discussing this, what we have seen, we discussed about the kinetic energy. So what will happen here? What will happen in the first case? If intensity increases, what will happen to the kinetic energy of the electrons? Will be constant. Can I write here only? Already we discussed that. So kinetic energy will be constant. It is independent of intensity. It is independent of intensity. Next point. So now, when this kinetic energy will change? And what do you mean by this kinetic energy? When this kinetic energy will change? For that, we have to discuss about frequency. Right? So second point, we have to discuss about what? Frequency. Now, try to discuss about this. If frequency increases, what will happen? Frequency of what? Frequency of the photon. If frequency of the photon increases, energy of the photon increases. So if frequency of the photon increases, energy of the photon increases. If energy of the photon increases, then what will happen? So the kinetic energy of the electron increases. In the sense what? Energy gained by the electron increases. Getting the point? If frequency increases, energy of the photon increases. If energy of the photon increases, energy gained by the electron increases. Energy gained by the electron increases. If energy gained by the electron increases, then kinetic energy increases. Now kinetic energy is independent of intensity and the kinetic energy is dependent on frequency, directly proportional. If frequency increases, kinetic energy increases. Already we have seen that. As on Einstein's photoelectric effect, we have drawn the graph. So what is the graph? So frequency and kinetic energy graph. We have seen or not? Already we have seen. So it is a straight line, not from the origin. So the slope always remains constant. What gives this one? So if frequency increases, then what happens to kinetic energy? Increases or not? Already we discussed this, not the new point for you. Right. Now, third point. Clear about this two? Already we discussed in the last class clearly. Next point. So for these two graphs also we know. What is that? Intensity and photoelectric current, frequency and kinetic energy we know. So what we want now? So we want the different graphs. We will see at the end. Okay? Now next point is about yesterday we are discussing about stopping potential. Right? So what we are discussing? We are discussing about stopping potential. Stopping potential. So what do you mean by stopping potential? So I think introduction part done. So no need to discuss about this first. I will change the little things here. Try to understand. Okay. So if you want, you can draw in the rough diagram such that you can understand about the stopping potential easily. Now initially cathode should be. Don't draw in the exams. You can understand this better. Okay. So initially cathode should be negative. And anode should be positive. In the sense, how the connection should be? Concentrate, this is negative. Negative connected to what? Negative connected to cathode. Right? See? And positive. So this wire, if I connect like this. Right? Clear about the point? So if I connect like this, then okay, cathode should be negative and anode should be positive. So no, see this wire, it came here. See, jumped here, it came here, and it is connected to positive side. Circuit. Try to see properly. Negative, see, try to see this wire. Right? See. Clear about the point? Okay? So now, initially, then what will happen? Electrons will move from one side to another side freely. Okay. Is that clear? Electrons will move from one side to another side, from cathode to anode. Now, what do you mean by the name itself tells stopping potential? We have to stop that. In a sense, whenever in mechanics, I think we studied if the body is moving with some speed, it came to rest. Retardation required. If retardation required, in the sense retarding force required. Now here also, what we have to apply? Some retarding force we have to require. In the sense, a retarding work done. So we have to apply some work on the electrons to stop that electron at that position. Why to stop? If the electron is moving from negative to positive, then current will be generated. So if the electron is moving from cathode to anode, then current will be generated. If it is not moving, if it won't move in the sense, electron is not moving from cathode to anode, then current will be zero. Current will be zero. Now you can ask, sir, what nonsense you are talking? So stop the intensity, then electron won't move. We don't want that. We don't want that. That photoelectric effect process should be there, then still photoelectric current should be zero. This point is important. That photoelectric process should be done, then still photoelectric current should be zero. In the sense, what we have to do? We have to vary the potential. If you vary the potential, then what will happen? Photoelectric process will be there. Then too the electron won't reach to the other side. How it will be possible? Now I will reverse the circuit. Reverse the circuit in the sense, not this type of reverse. Terminals in the circuit I will change. I will reverse that. So how we can reverse? See. So initial case negative, positive. Then electron ejected out, positive side it is attracted, so electrons went that side, so current double. Now, reverse the things in the sense, now I will make cathode positive and anode negative. Understood the point? Now I am making what? Cathode as positive, anode as negative. So that's why this commutator part is very important. That is like the communication system for these two parts of the circuit. Right? Clear about the point? Now try to understand. So how we can change? Now I want cathode positive, anode negative. Now I'll join these two in the sense anode came to this side, cathode came to this side. Now what I want? Cathode I want positive, right? See? So this should be connected to this side. So what I will do now, simply I will connect these 2 points. Right? So now what is this part? Anode. Now anode should be negative. Simply I will connect these 2 points. These are just connecting wires. Don't worry, we can connect anywhere. You can connect to here, you can connect to here. So don't worry about that. Now try to understand. See the circuit, analyze the circuit first. Cathode. What positive? Right now, cathode is positive. Now anode side. What we got? Negative. So what I assumed I did from the experiment, I did from the circuit, right? So now why I am doing like this? Try to understand the point. Why I did like this? Why? In a sense, this photoelectric electrons should be generated, then to the current in the circuit should be zero. That point you have to understand. So for that, if I make it as positive, then what will happen? So photons came, assume I am cathode, photons came and strike the beam. What will happen? From me electron came out, but I am positive. Electron came out, but I am positive. So electron came out and it is trying to go, because it has some energy, right? So it has some energy, it is trying to go. But what I will do? I am positive, that is negative. I try to attract. If I try to attract, then what will happen? Up to some extent it will go and it will come back. If energy is 2 more, 1 minute. If energy is 2 more for the electron, if energy is 2 more, then what will happen? The electron, it will reach to anode. Current will be there still at a particular voltage. Now this voltage we have to reverse. See, we reverse the we reverse. So anode we got it as negative. So we call it as anode potential. Now whatever will vary here, we call it as anode potential. What type of potential? Anode potential. In a sense, negative potential. Anode potential, or we can call it as negative potential. Try to understand the story, simple. If you understand the story, no need to read again. Right? So photon came, strike the surface, and electron came out. Yes or no? So the electron is having more energy. With this voltage, for example, I applied assume negative voltage, no, -1 volt I applied, for example. Okay, -1 volt is there, the potential difference between cathode and anode. Still electron went to the other side. In the sense what? Compared to my voltage, compared to the given energy, electron energy is more. It went to the other side. Okay, it went. Now what I did? I increased. My energy I increased. Right? So electron came out and now also it went. Yes, and still that energy is more. But what about the energy? Kinetic energy decreases. Getting the point? And trying to attract. Still it is by forcibly it has some energy, inbuilt energy, so it is trying to go that side. Okay, man? So no problem. 3 volts. Finally it went. It reached. Okay? So now -4 volts. Assume this is my experiment. I am taking my value. 4 volts. Now it didn't reach. Assume electron came to the nearest to the anode and again reversed back. Why? Attractive force is there. So now, according to me, at this negative voltage, what happened? The electron went to the other side and it didn't reach anode. Why? Because my energy is more compared to the electron energy. My energy is more. If my energy is more, then what will happen? It went to the maximum extent and it returned back. Then what will happen to the current? 0. So now, at this particular voltage, photoelectric current we got as 0. What is VC? Photoelectric current is 0. At that particular voltage, we got photoelectric current 0. That voltage we got as stopping potential. What we are stopping? We are stopping the photoelectric current in the circuit, in the experiment, or in the circuit. So, at photoelectric current is 0, at what potential? We call it as stopping potential. So, clear about the point? The potential required, the negative potential or the anode potential required such that the photoelectric current is 0 is called stopping potential. Okay, the potential required for the anode, or the negative potential for the anode required such that the photoelectric current is zero. We call it as stopping potential. The negative potential, or some say it as anode potential, whatever. Negative potential or the anode potential required such that photoelectric current is equals to zero is called stopping potential. At that particular voltage, what will happen? Current will be zero. We call it as stopping potential. This is another thing you have to remember. Now, stopping potential depends on what? This is the basic story. Clear about the point? Try to write this. Now we will discuss more about this stopping potential relations. Okay. So now stopping potential depends on what? What is the formula for stopping potential? I think we have seen in the last class. Stopping potential. What is the kinetic energy will be there? We have to apply some work on that against to that kinetic energy. So electron is coming in this direction. So for example, I am the battery. What I have to do now? Why we got minus values? So we have to apply the work on the electrons against to the work what it is having. It is having some kinetic energy, so it is moving. Now what I have to do? I have to apply some work on the electrons against to that. Then it won't reach to the anode. Clear about the point? So, right. Now what is the formula for that? Work done. That work done is nothing but the energy what we have to supply. Actually, we have seen. What is the kinetic energy of the electrons? EV. Right? Now what is the work done I have to do on that? That is also EV only. So work done is nothing but charge into voltage. Now what voltage we have to apply on that? Stopping potential. What voltage? Stopping potential we call. What potential? Stopping potential. So we will write it as V0. That V0 indicates what? Stopping potential. So this work done will be converted to energy. Right? This work done will be converted to energy. V0. This work done converted to energy. In terms of stopping potential, how we can write? We can write as EV0. So how much energy we have to give on that? EV0 we have to give on that electron such that it will come to rest. Formula wise, it will be EV0. How much energy we have to give on that? Against that, it will be EV0. Okay? Right. Now, stopping potential depends on what? Stopping potential depends on what? So if you understand this, then we have to draw the graphs and show this, right? So stopping potential depends on what? Right? Tell me. So can I tell stopping potential depends on intensity? So I write something. Try to answer yourself. Okay. Depends on. Stopping potential depends on frequency. First step is true, then I like some more points such that you can understand it easily. So stopping potential depends on intensity. Absolutely wrong. We know. Why? So intensity increases in the sense photoelectric current increases. Then stopping potential no need to increase. Why? Because the energy of the electron is not increasing. It is moving okay, more number of electrons coming out okay, but energy of the electron is not changing, right? So stopping potential depends on frequency, absolutely correct. So if frequency increases, energy increases. If energy increases, yes, it will go to the other side with more energy such that we have to vary the voltage more, negative side. Negative side we have to vary more. Yes or no? So stopping potential depends on the frequency, not on the intensity. Clear about the point? Right? So now, draw the graph. First we'll draw the graphs or question. Okay, question. We'll draw all the graphs at one place. You can understand it easily. Okay. For example, concentrate. Intensity I am increasing. I maintain frequency constant. So before going to these type of questions, another concept you have to understand for a minute. Okay. Saturation current. Saturation current. So what do you mean by this saturation current? So it's not reverse concept now, don't worry about that. So again go back to the original concept. So cathode is of positive and cathode is of negative and anode is of positive. Original concept, not reverse concept. Original concept. So cathode is of negative and anode is of positive. Right? So now what do you mean by saturation current? What do you mean by saturation? Saturation in the sense constant. Wherever you can see saturation, that means constant. That means constant. So it depends on what? And what do you mean by that saturation current? When the current will be constant. Try to understand. Now, if intensity increases, what will happen? So consider a metal surface or cathode, whatever. So photons are striking, electron is coming out. So electron came. First two photons strike, 2 photons. Electron won't come out generally. 0.1 to 1% will come out. 2 photons in the sense electron will come out. No. So 1000 photons, 1 or 2 came out. 2000 photons, maybe 2 or 4 came out. So how many number of electrons will come out here? If electrons come out in the sense, the photoelectric current will be generated, right? So now continuously I am increasing the intensity. Assume I have a mission. So in that I can increase the intensity. Somewhere around here I can increase the intensity. So I am observing that. If intensity increases, some electrons came out. Assume 10. Still further 20, further 30, further 40. Up to what extent it will come? It depends on the metal. Continuously it will come. So 1000 volts I applied the potential. Intensity I increased. Then what happened? Some particular point will be there. Okay, up to that point the electrons will come out. Beyond that, how much intensity if you increase, electrons won't come out. It depends on the material. Understood this point? It depends on the material. So if intensity increases, electrons will come out. Further increase, came out. Further increase, electrons came out, increased. Up to some extent, these electrons will increases and it will come out. Beyond that, if you increase the intensity, the number of electrons which is emitting out of the metal won't increase. If they won't increase, current also won't increase. Will be constant. That particular current we call as saturation current. Clear about the point? Saturation current is a constant current. So up to a particular intensity, the electrons will increase. Electron emission will be increased. So at a particular value, beyond that, if we increase the intensity, then what will happen? Electron emission won't increase. Electrons will come out, but that rate won't increase. If that rate won't increase, current won't increase. That will be constant. Further, how much intensity you increase, current will be constant. In the sense, the emission of electrons at that second won't change. Right? So that current we call as saturation current. Constant current, please try to remember that. Definition is not that, try to understand the point. Okay? So, is that clear about the saturation current now? Okay? Now my question. So after saturation current, write some points what you understood. So at a particular value of intensity, the emission of electrons increases for a metal. Beyond that, if you increase the intensity, electron emission will be constant. They won't increase. If they won't increase, then current also won't increase. Current will be constant. So that particular constant current we call as saturation current. That particular constant current is called as saturation current. Rewind the thing and try to write that point. So in the proper manner it came. So try to write that point. Then we will continue. Clear about the saturation current? Okay, right. Now what I am doing? Try to see the experiment. Intensity increases, I increase the intensity, and I maintain constant frequency. If I write equals to constant, alright. So I maintain constant frequency and I increase the intensity. Then what will happen to stopping potential and what will happen to saturated current? My question, understand the question? I increase the intensity of the light and I maintain constant frequency of the light of the source. Then what will happen to the stopping potential and what will happen to the saturated current? Think about it. Next, I maintain intensity constant. Like this, we can write n number of probability cases. So one or two I will write, such that you can understand it easily. Then almost done. We have to draw the graphs and we will move to the matter waves. So if half an hour time is there, yes, another half an hour, we can close the topic today, right? So intensity, constant, and frequency. What I am doing now, I am decreasing. Can I keep an arrow on like this? Right? Frequency decreasing. Now what will happen to the stopping potential? What will happen to the saturated current? Think about these two. Think about these two. Then we can write n number of probability cases or one or two. Try to think about this. Okay? So what will happen? Intensity increases, frequency not, but stopping potential. This is stopping potential. Don't be confused. And this is saturated current. Okay? So frequency constant, saturated current also will be constant. No need to think about that. So intensity increases, then saturated current increases. Yes or no? Saturated current depends on intensity. Why? If intensity is more, number of electrons coming out will be more. Now, I am not talking about energy, I am talking about number of electrons coming out. So intensity is more, number of electrons coming out will be more. Then current will be more. Then saturated current also will be more. Okay? So we draw the graphs there, you can understand still if you have any doubts there. So intensity constant, frequency decrease. What do you mean by this? Very important point. So can we do like this in the experiment first of all? Intensity is constant, in the sense number of photons striking should be constant. Think about that. Frequency decreases. If frequency decreases, here you have to understand this point, right? If frequency decreases, energy of the photon decreases, right? So energy of the photon decreases. Now we want the same brightness. Try to understand this point. Same brightness. In the sense what? Initially the brightness is 100, for example. Now energy decreased. Consider one photon, intensity is 2 more, assume it has 100 units. Now energy decreased. What will happen to that? Energy is less. If energy is less, the same brightness will be there or small changes will be there. Definitely changes will be there in the intensity. Why? Intensity is nothing but energy per unit area per unit time. Energy is less in the sense intensity will be less. Got the point now? If energy is less, intensity will be less. So now, frequency decreased, energy decreased. If energy decreases, the brightness, intensity decreases. Now I say intensity constant. So how nonsense we can take intensity constant? So that what we have to do, we have to send more number of photons. Yes? Try to understand this. Frequency less for a photon. Frequency less, energy less. Energy less, brightness. That intensity will be less. But I said I am maintaining the constant intensity. How it is possible? So 100 units now became 50 units. To maintain intensity constant as 100, send another photon. 50 plus 50, 100. So in this situation, what we have to do? We have to increase the number of photons. In the sense, number of photons increases. Most of you will be getting confused here. Sir, up to now what we studied we forgot. Why? Intensity constant in the sense you said number of photons constant. Okay, we are in that track. Now you are telling the intensity constant, the number of photons increasing. How nonsense possible? Possible. Then it will be possible if frequency decreases possible. Energy decreases. If energy decreases, intensity decreases. To maintain the constant intensity, number of photons, if I produce more, if I send more, then what will happen? Again, intensity will be constant. 100 units became 50. Now I want 100 at that surface. What you have to do? Send 2. 50 plus 50. What happened? 100. So number of photons we have to increase in this situation. Clear about the point? So now tell me what will happen. So frequency decreases. What will happen to the stopping potential? Definitely decreases. Definitely decreases. Understood the point? So frequency decreases, then definitely stopping potential decreases. Then what will happen to the saturation current? What will happen to the saturation current? Try to understand the point. Now number of photons striking increases. Number of photons striking increases. Energy, okay, decreases. Number of photons striking increases. If number of photons increases, saturation current also. Is that clear about the point? In this situation, generally not according to your NCRT, beyond if you think it will be like this. So what will happen to the saturation current? Increases. Why increases? Number of photons increases. If number increases, 0.1 to 1% of the electrons will come. That also percentage thing, if we think, the electrons also will increase. If electrons increases, then photoelectric current increases. If photoelectric current increases, saturation current increases. Clear about the point? Try to write this one properly. Good one. So remaining things we can tell it easily. So individually, if you compare, I think you understood. So relation will be there for intensity and frequency also. We can tell like this. Okay. Now we can do many things here. We can waste much time here. Intensity constant, frequency increases. What will happen to number of photons? Decreases. What will happen to saturation current? Decreases. What will happen to stopping potential? Increases. Write this point also. Third one. Okay. So next graphs. Come to graphs. So up to now, what you understood? We have to draw the graphs. First graph. Intensity versus photoelectric current. Already we know. So intensity versus photoelectric current. Straight line passing from the horizon. No need to waste much time. Next, what we know, we have to draw the graph for photoelectric current and anode potential. Photoelectric current versus anode potential. Try to understand? Very important graph. In tomorrow's discussion paper, last 6 questions based on the graphs only. After this 5-10 minutes, we will discuss those bits and we will complete those 6 questions. Okay. So photoelectric current and anode potential. So this is anode potential. So positive side of anode potential we don't want. Yes or no? So we want negative, reverse, right? So we want negative side. So tell me, what will happen actually? Think about that. So if anode is positive, for example, if anode is positive, then electrons will go. Try to think, this is positive side, this is negative side. So anode is positive. If anode is positive, electrons will go, photoelectric current will be there, and for example, if intensity increases, then what will happen? Saturation current increases. Yes or no? So now, positive side, what will happen? Current will be there, definitely. Now we have to concentrate on the negative side. So slowly what happened? Anode positive side too came to zero, and further negative. So if it is a negative side, then what will happen? If I increase the negative side, 0, 0, -1, -2, -3, at a particular point, what will happen? Photoelectric current will be equals to 0. Already we discussed, right? So at a particular point, photoelectric current will be 0. Yes or no? This point we call as a stopping potential. Anode potential is this axis, and this point we call as a stopping potential, right? So here potential current will be equals to 0. I think you are understanding the thing. At this point, current will be equals to 0. Now slowly if I increase, see, -4, -3, -2, current increases or not? Yes. So further also it will increase, and then finally it will come to the saturation point. I think you understood about this now. Saturation current. Yes or no? Saturation resistance current will be constant, so the curve will be like this. So here stopping potential at this point V0. So stopping potential. So further what will happen here, current will be equals to 0. So further minus 4 assume minus 3, current is more, minus 2 more, minus 1 more, 0, further more. Then again see increase and further it came to the saturation current. See current up to this extent it is increased and then it became constant. So this part we call as saturation current. Saturation current. It depends on metal to metal, it will vary. Don't worry about that. Don't worry about that. Can I draw different metals? See? Okay, so visible, right? So consider it as I1, red I2, and black as I3. So I1 blue, I2 red, and I3 black. So which intensity will be more? My question. Which intensity will be more? Which intensity will be more? Answer yourself. So I think you can tell which intensity will be more. So if intensity will be more, then only saturated current will be more. We know that. Intensity more, number of photons more, number of electrons more, saturated current will be more. So in these three, saturation current more for I1. So I can write I1 greater than I2 greater than I3. Then what about stopping potential? It will be same for all. See, stopping potential is same for all. And only intensity changed, not frequency. Not frequency, intensity changed. So that's why, so intensity changed here. Intensity is changed. Now the same graph, if you vary frequency, can you draw it? Is that clear? Next graph. Same again, photoelectric current and as well as anode potential. Photoelectric current and as well as anode potential. Third graph. Photoelectric current versus anode potential. Anode potential. Okay? Anode potential. So photoelectric current and anode potential. Okay? Now, here intensity is changed. Now I vary frequency. Frequency is changed. Keeping intensity constant. Keeping intensity constant. Constant. Okay? So how the graph will be. Now what will change if frequency changes? Stopping potential changes. Now the same graph, see. 1. Now what should be same? Saturated current should be same. Yes or no? Why? We are not changing intensity. So saturated current should be same. And maximum current also should be same. All the conditions you have to remember. Not simply drawing the things. Okay? Okay, next, another frequency. So this is stopping potential, V01, V02, V03. Alright, so stopping potential varied. Why? Frequency is varied. Now what about saturation current? Saturation current is constant because intensity is constant. But stopping potential varied. So which one is more? This one will be more. Yes or no? So why? Because frequency will be more for this one. So that's why stopping potential also will be more. So stopping potential of 3 greater than 2 greater than 1. In the sense frequency 3 greater than 2 greater than 1. So assume as F3 and assume black as F2, blue as F1. So this is about the different graphs. So already we know about the stopping potential and frequency graph. Draw the stopping potential and the frequency graph. Draw the stopping potential and the frequency graph. Sir, how to draw? Stopping potential, last one. Stopping potential and the frequency graph versus frequency graph. So how? So we know the Einstein's equation. What is that? So energy of the photon, which is equals to work function plus energy of the electron. Can I write? Yes or no? So now energy of the photon, Hc or Hf, which is equals to Hf naught plus kinetic energy. This kinetic energy, stopping potential is nothing but what? Kinetic energy work done on the electron. So I can write this kinetic energy as stopping potential. Understand the point? Energy of the electron. Visible, right? So energy of the electron, right? So energy of the electron is nothing but what? So we have to apply some stopping potential on that. So that will be equal to that. Can I write it as EV naught? Clear about the point? Now EV naught. Is that okay? Now stopping potential graph V naught we want. So what I can write EV naught, which is equals to HF minus HF naught. So V naught, which is equals to HF by E minus again HF naught by E. Now again this is in the form of y equals to mx plus c, negative intercept. And what is the slope now? H by E. There we got H. Now here it is H by E. Now graph will be along y-axis. It should be stopping potential, and along x-axis it should be frequency. Now tell me same graph, but slope will be different. What is that? There it is H in Einstein's photoelectric effect. Here it will be H by E. Here it will be H by E. Right? Clear about the point? Right? So H by E. So negative slope again. Negative slope in the sense for V naught it will be negative if F is 0. In the sense it will be somewhere around here. So same curve. Metal A. Right? Metal A. Metal B. So same question I can ask. For which metal work function is more? For which function? For which metal work function is more out of metal A and metal B? Again for metal B itself by extend both. So this will give you the work function, and here it will give you the threshold frequency. This is threshold frequency, and on y-axis negative side will get what? Will get the work function. Already I have drawn the graph. There I mentioned along y-axis phi 1 and phi 2. If you remember, see that graph. Okay. So for metal B, work function will be more compared to metal 1. But what about slope? Slope will be H by E. Slope will be H by E. Clear about the point? So this is the fourth curve. Fourth curve. So all the four curves clear. Intensity versus photoelectric current, and photoelectric current versus anode potential, keeping intensity constant. And next again same photoelectric current and anode potential, keeping frequency constant. Next fourth one, graph for stopping potential and frequency. If you know all these things with the experiment, so the experimental study of Leonard and Hall-Winch is done. Hall-Watch is done. Clear about the point? So everything we discussed, try to see those points, right? Now very small topic is there after this, matter waves. Just 10 minutes. Why? Because in your NCERT that matter waves topic is too big, but according to me it is too small. Why? We started the chapter with matter waves. See my the first video of this chapter. So we started with photon. We started with the properties of the photons. We continued with de Broglie's things. Lambda equals to H by P. So all the things considered matter is, but first you have to know about the photon. So that's why we started like that. Alright? So we'll quickly revise that and we'll close the theory part today, and tomorrow we'll do the questions. Theory questions, don't waste time, 20 to 26. If you have that paper what we sent yesterday, please try to see 20 to 26 bit numbers. You have to answer those. You have to analyze those after this story, right? So story done, you can do now. So keep that in, matter waves. Okay? Matter waves. Simple thing, maybe around 15-20 minutes story. It's there, right? Now, matter waves. Matter waves. Oh, what nonsense. Matter. Everything is a matter. If you throw the pen, it will dance or it will go straight. It will go straight. So, why I get matter waves? Now, try to understand the point. De Broglie. Here again, De Broglie will come. So, De Broglie came here. And he said about the photon. Light is a wave. It is the form of what? The number of photons. We know that. So, the photon. Now, photon came to know that it is having particle. It's an important point. Concentrate. Now the photon came to know that photon came to know that it is having particle nature as well as wave nature. Photon came to know that. Now the photon, it will sit simply. If you know any important thing, you will sit simply. You will tell your friends like that. Photon also said the same thing to his friends, like electron, proton, alpha particles. So more friends are there. He said to all his friends. Now electron also came and asked De Broglie, only photon having a dual nature, not for me. Then De Broglie started thinking again. Actual story. Okay? So it's not happened, assumption. Okay? So electron came and asked De Broglie, and De Broglie started thinking that okay, only for photon dual nature will be there, not for you. Let me check. So he checked and said, all the particles having the dual nature, all the particles having the dual nature, but condition, but the wavelength of that particles should be incomparable with the size of the particle. Incomparable in the sense the wavelength and the size of the two should be comparable. We can compare in the sense that much small it should be. Then we can tell all the particles will be having what? Dual nature. Understood the point? Write the point. So all particles will be having dual nature, particle and wave nature. So when it will be possible, condition. When it will be possible, in the sense, the wavelength of the particles. So, right, wavelength, right? So, the wavelength of the particles is comparable. Wavelength of the particles is comparable to the size of the particle. Wavelength of the particle should be incomparable to the size of the particle. Then again doubt arises. Sir, what is this nonsense? So for that, can I take an example? Is that clear about the story? Photon having dual nature, and why not for the other particles? So De Broglie did some experiments again, and he said for all the particles in the matter having the dual nature, but this condition should be satisfied. Then what about this condition that we have to see? So what about De Broglie's wavelength? Answer yourself. We discussed in the dual nature first video, right? So I can write lambda which is equals to h by p, right? And we can write p equals to h by lambda. Then we have to use which one? That also I said. If you want the particle nature from the wave nature, P is what? Particle nature, momentum. From what? From wave nature. Then P equals to h by lambda. Now what we want? Now we want wave nature from particle nature. Now what we want? Now what we want? All the particles is having particle nature. If I throw the coin, it is having particle nature. Then it will be having wave nature or not, we have to calculate. In the sense, we have to consider lambda equals to h by b. Not b equals to h by lambda. Both are same only, but small change. Lambda equals to h by b. Now I can write lambda equals to h by mv. Now it depends on the mass, it depends on the velocity. Now, an example. Consider a block of mass 1 kg. Consider a block of mass 1 kg. It is moving with a speed of 10 meter per second. Consider a block of mass 1 kg. It is moving with 10 meter per second. How it is moving? Leave that nonsense. Okay. So 1 kg, 10 meter per second. It is moving. So find the wavelength I asked. So one student asked me, sir, whether it will exhibit wave nature or not. Okay, but don't worry. First, calculate lambda and F2V. I asked. So we started calculating. So h value is 6.64 into 10 to the power minus 34 divided by mass of the particle is 1 and the velocity is 10. So which is equals to 6.64 into 10 to the power minus 35 V. 10 minus 1, 35. So see this one, is this small or big? Sorry, in meters only we got? Yes, in meters. So 6.64 into 10 to the power minus 35. Very small. Yes, very small, very small. So the size of the particle is 1 kg in the sense, somewhere around, it depends. So now if I compare these two, see the wavelength? Too small, very, very small. We can't observe that. If this block is moving with 10 meter per second, yes, the particle is vibrating. I think you understand this point. So if you are going in a car with too much speed, you are going in a bike, for example, with 200 kilometers per hour, we can go, right? 200 kilometers per hour. You go in a straight line path? Definitely not. Some vibrations will be there or not? Definitely will be there. In a sense, that particle also will vibrate. But that wavelength is not very less. We can't imagine that and we can't calculate that. So that's why he said the wavelength of the particle is incomparable to the size of the particle, or you can tell the mass of the particle. Size is exactly correct. So we can call it as a mass of the particle also. Now for example, electron I considered. What is the mass? 9.1 into 10 to the power minus 31. So if I substitute here, and is going with the speed of 2 into 10 to the power 8 meter per second. Chances are there. 2 into 10 to the power 8 meter per second. So calculate the wavelength. You will get small. That is in comparison 9.1 into 10 to the power minus 31. Approx you will get the same value. Then those type of particles will exhibit both particle as well as wave nature. It is moving, and while moving, wavelength is there in the sense it is dancing. But this one also wavelength is there, but very small. We can't even calculate that. So that's why he said this convention. Clear about the point? Right? So this is, we call it as a de Broglie wavelength for the particles. If you want a heading, you can write lambda equals to h by p. This is the de Broglie wavelength. De Broglie wavelength for the particles. De Broglie wavelength for the particles. How? Lambda equals to h by mv. So basic thing, clear about the point? Now all the particles will exhibit the dual nature, particle nature as well as wave nature. All the particles, I am not talking about the bodies, particles. Now next point. So lambda equals to h by p. Now we got. Okay, very good. So this is momentum. So now one more formula I can write as h by momentum and kinetic energy formula we know. So in 11th we studied kinetic energy, which is equals to half mv square, right? So multiply and divide with m. So I can write m square v square divided by 2m. So mv whole square v square by 2m. This is what? Momentum. So momentum, which is equals to square root of 2m into kinetic energy. Relation for momentum and kinetic energy, square root of 2m we know. Now come back to this concept. So one experiment is there that you have to understand. Try to understand that for a minute, not more time. So this we call as, so try to understand. So only one type of emission we discussed. What is that? Photoelectric emission. One type of emission we discussed. What is that? Photoelectric emission. Now, according to your book, more types of emissions are there. What are those emissions? Those who studied, answer yourself. So first one is photoelectric emission. Types of emissions I am telling. Electron emission. There I said more types will be there. So we are discussing only about photoelectric emission. Different types of emissions we will see later. So we are discussing now. So photoelectric emission. So first one is about photoelectric emission. First one is about photoelectric emission. Second one, thermionic emission. Third one, field emission. Yes, field emission. Fourth one, secondary emission. Secondary emission. So first topic according to NCERT, last topic according to me. Why? Because why to deviate? Why to deviate? So, sir, why here also? So a point is there, so that's why I have written. So photoelectric emission, after we discussed, don't need to waste time. Okay. So thermionic emission. The emission of electrons from the metal surface due to the rise in the temperature. Thermionic emission in the sense what? Thermionic. In the sense temperature. Due to the rise in the temperature, electron is coming out. Due to the rise in the temperature, electron is coming out. Those type of emissions we call as thermionic emissions. Now we'll use that. That's why I have written. Field emission. So consider metal surface which is placed in a strong electric field, which is placed in a very strong electric field, for example 10 to the power 8 volt per meters. So that much strong electric field, in that I place the metal surface. What will happen? Some force will be there on the charging part, on the free electrons inside. So due to the force, what will happen? The electron chances will be there, it will come out from the metal surface. The electrons force will be there due to what? Due to the electric field. Then the electron chances will be there, it will come out due to that electric field. We call it as field emission. Secondary emission. So for example, for secondary emission, definitely I have to draw the diagram. So consider metal surface, free electrons will be there. Secondary emission, in the sense, I am not placing any photons. So like photons only, this also it can work. But thermionic, we are not rising any temperature here. We are not placing any strong electric fields there. But here, secondary emission in the sense, we have to send any particle, whether another electron, fast moving electrons, very fast. So consider metal here, in that free electron is there. So in atoms we will get this point. In atoms we can see. So consider a fast moving electron came or any other particle. It hit that. What will happen? That electron chances will be there. It can come out. It can take some energy from the fast moving electrons and it can jump. Games, right? So it is coming with very too much speed, too much energy. Then it can try to use some energy. Yes. So it took some energy and it can run. It can run in the sense it can come out of the metal surface. That we call as secondary emission. Clear about the things? Right. Come back to the point. Now here we will use thermionic emission. How? See, consider a filament, a metal surface. According to you, it is a metal surface. According to me, call it as a filament connected to a high voltage battery. It's an experiment again. Don't worry about that. High voltage battery. Due to this high voltage battery, what will happen? Current will try to go. Current will go in this bulbs. I think filament in the sense you know. Take a bulb, switch on that. After some time, touch that. What will happen? So heat will be there. Heat will be generated. Yes or no? So why heat will be generated? So that we call as thermionic emission. In the sense, due to the current, heat will be developed inside. Due to that heat slowly increases or not? Yes, increases. After increasing, up to a certain extent it will increase. Then what will happen? Slowly the particles will come out. What will happen? Slowly the particles will come out, right? So now, due to this process, that process we call as thermionic process. Now, so connected a battery, current is going. Now this is a filament. Now it will get heated. So if it gets heated, then what will happen? Electron slowly it came out from the element. Slowly it came out from the element. Just it came out from the element. Try to understand? It came out from that element. Now what I am trying to do, this thing I am placing in an evacuated tube again with a small hole or empty space to come out of that hole. This electron should come out of that hole. I left a small gap there, small gap. And again, this thing I connected to a battery which will maintain a potential difference. Try to understand, nothing simple. This is the filament connected to a high voltage source. This is high voltage source. And it is connected to a battery, very small voltage battery. So why this battery? To maintain the potential, difference. See here, negative side, can I tell this side as 0? Can I tell this side as B? Right? So due to this high voltage source, electron came out. That's it. Electron came out. Now due to this potential difference, what will happen? The electron will accelerate. Understanding the point? So this is 0 and this will be V. Potential difference is there. Electric field is always from higher potential to lower potential. So electron always will move opposite to the direction of the electric field. So electron will move with the constant speed or it will accelerate. Definitely it will accelerate. So accelerate and it came out. Now what is the energy of the electron? So due to points, point A and point B. So total energy at point A and total energy at point B will be same. In the sense, total energy at A, kinetic energy at A, potential energy at A, and kinetic energy at B, potential energy at B will be same. Why? Only conservative forces are there. Okay. So at point A, just it came out. So 0 and potential also 0. So potential energy also 0. Now kinetic energy visible? Yes. So at point B, so kinetic energy is there. It is accelerated at point B. Some kinetic energy will be there. So what is the potential here? Electron potential is V. So potential energy is minus EV. So 0 which is equals to kinetic energy minus EV. So kinetic energy which is equals to EV. So why I did all these things, you know this. But according to the de Broglie, he did this experiment to tell kinetic energy value which is equals to EV. Now we know momentum. So which is equals to square root of 2m. Kinetic energy is nothing but EV. Right? So according to de Broglie wavelength, h by p, final equation, h by p. So p is what? Momentum. So lambda which is equals to h by, what is momentum? The square root of 2m EV. So final relation of the de Broglie wavelength. Very important. So final relation is what? Lambda equals to h by square root of 2m EV. So whatever the particle may be, we can calculate lambda. Whatever the particle, whether it is electron, right? So whether it is a proton, whether it is alpha particle, whatever it may be, you can substitute the values and you can calculate the lambda. But potential is important. What? Potential, what we applied is important. Right? So this is the de Broglie's hypothesis in the matter waves. Clear about the point? Right? Try to revise this. In the tomorrow's class, first 3-4 minutes we'll discuss about this formula for different particles. Then we'll do the questions. Now your task for today, bit number, theory paper, I think discussion paper already I have sent. The question number 20 to 26 you have to do. Try to analyze. Right? Then remaining 20 questions we will see in the tomorrow's class. Those 6 questions also I'll give the hints. Right? So thank you. Bye. We'll continue in the tomorrow's class.